Thanks for the introduction. Thanks very much for listening to us. So between us three, we'll be talking to you about sort of our perspective on adapting an aging infrastructure going forward to the challenges of the future. I'll kick us off by talking about, I think Jane earlier mentioned a bit about Vineyard Farm. I'm just going to talk a bit about my experience as a young graduate joining the railway and why this project stood out to me so much, and why it inspired me to stay in the railway and keep working towards our sustainable targets. So, about Vineyard Farm. Quick overview. It's located on the line that connects Newport to Shrewsbury, a very important line. Lots of people use it. If you need to travel to the north of England or the north of Wales, it's basically the only route you've got. It's actually part of Network Rail's Wales and Borders route, which means that we cover the borders as well, which is why, even though it's 20 metres within the English border, it still comes under Wales and Borders route responsibility. So why has this been a problem? Why has this site sort of caused us grief in the past? There's a river near the site which floods most winters, as a lot of rivers do, especially with a lot of rain. This was seen especially so in the sort of winter of 2019 to 2020, where the line had to be closed twice for 7 days each time. And you can begin to think how many delay repay minutes that's going to cause, etc., etc. With changing climate, this can only get worse with more freak rainstorms, like just more crazy events that we're seeing all the time. The last few weeks is evidence enough of how much rain we might be expecting coming forward. So something had to be done, because we can't keep having pictures like that happen on our railway. To go into more technical detail about why these washouts are happening, as you can see, pointed there, where the H and L1 sign is, that is where the river goes under the bridge, the railway bridge. It's quite a low bridge, so when the river level rises, the water actually starts to get caught by the bridge. The bridge prevents the water being able to flow as it would normally. This water has to go somewhere because it's cascading down at a high velocity. The only thing it can do, flow inland. So it gets sort of like a bathtub effect. It gets wedged between the hill, which is in the sort of the higher bit of the picture, and it gets trapped between the railway embankment as well. And you get this bathtub effect of water just building up. This water is naturally trying to get to the lowest point in the ground, where the water table flows to. So, as you can see in the picture on the right, the water washes through the railway as it attempts to get to the river in the lower area. As it does this, it takes everything with it, ballast, other assets, you name it, everything goes, it gets washed away, and that is why you get such damaging effects, and why the line has to be closed for really long periods of time, longer than the actual flood event itself. And the whole process is called overtopping. So many solutions were considered, but the proposed solution that was gone for in the end was some rock armour, placed very carefully, starting, you build it up kind of like a jigsaw piece, and this rock armour would be fitted to the downslope side, not the upslope side, which a lot of people might think is the way you do it. When you have a coastal protection, you think you have to face the water front on and put the rock down that way. But no, the rock armour actually goes on the downslope side. The plan behind this is that the water will flow. It will still flood, but the rock armour in place will slow the floodwater down. It will take energy out of the floodwater, and this would allow the ballast to stay in place because the water wouldn't have enough energy to wash things away with it. So your bathtub analogy I had earlier, instead of just pulling the plug and letting water just chaotically flow away with high velocity, you're kind of putting a filter in and you're letting it seep out, which allows a more controlled flood event. It's worth pointing out that we're not just letting it flood without a bit of monitoring or anything. We've put monitoring equipment in, so we know to close the line still if we're expecting the river to flood. But the idea is that the line will be closed for days rather than weeks, which is still a much bigger improvement. I forgot to mention as well the existing drainage. I'll go back. The existing drainage was also factored into the design, and the culverts were extended because obviously drainage is extremely important. a few pictures of work in progress. You've got your geotextile being laid down. As I said before, you've got rocks being carefully placed, start building up from the toe, kind of like a jigsaw piece. And this basically allows the structure to stand as one without additional support being needed, which is another example of smart, efficient engineering. And as I said before, only the downslope side is required. This is where the water overtops. So your finished product, you're looking at 8,000 tons of rock armour, plonked on the downslope side, but plonked very carefully, and everything had a place. Total cost, £4.571 million to date. I think there's still a few minor costs to cover, but the bulk of it is in that figure there. And an important point, which I'll get to in more detail later, limestone was used from the local quarry, Macon Quarry, and this will show why this was so smart and important later. A quick question to the audience. These are some pictures of rock armour being delivered to the site. Can anyone spot what is unique or interesting about these pictures? Sorry? Spot on, exactly. The rock armour is being delivered by train. And this is the main reason this project stood out to me. And why is that so good, you might be wondering? Only 8 freight trains were used. If lorries were used, you'd be looking at 320 lorries. I haven't done the carbon maths, but we've had some talks on carbon tools earlier, I think, so that might be a way to work out. But it's a lot of carbon we are saving by being smart and using the railway we work on every day to actually deliver our goods. It's also a smart solution for access issues. Large lorries driving around the windy Welsh roads of the countryside, you'd lead to a lot of problems. I think someone might want to correct me, but I think this is the first time since the 70s, rock armour has been delivered by train for a railway construction project, which is pretty cool. But I don't see why we can't do it more, given we have such a vast network of railway. Other points that stood out to me when I was studying this project, ecology was considered. We have to factor it in to any design we do, and I really like the way we did that. Again, I spoke about the limestone. It's the only type of limestone from Macon Quarry that it's a very hard limestone, and it's the only one that qualifies with engineering standards to be used as rock armour. So by doing a bit of research, by realising that we can actually use limestone locally, we were able to save not only money, but carbon emissions again, because the other option was to drive in, granite from hundreds of miles away, which again, it's these idea about doing smart research and then executing it, in a clever fashion. You can really you can save some unnecessary problems. Again, I really like it to protect over prevent philosophy. Other solutions look to completely eradicate the risk of flooding, but this would have cost so much more, and you've had real access issues. Possessions cost money. They also delay passengers and freight. You want to keep possessions to an absolute minimum. And this solution only used three weekend possessions. The rest of it could be done while trains are running. So it's, again, a solution where we've tried to put passengers first and do what we need to do, make sure it's safe, while keeping the railway running. Because if you have to close the railway, I get it. But if there's an option to keep it running and then do your solution, that's brilliant, because everyone stays relatively happy. So linking back to why we've stood up here, this project is adapting to the future challenges in an environmental sense, because it's a significant carbon footprint reduced, not only in the actual construction itself, but actually all the delays we've saved, by delivering it by train. As I said, we've kept lorries off the road, but also by not causing all these train cancellations for many possessions. If you think about all the replacement bus services we'd have to put in, it's really, helps a lot in the sense of keeping carbon to a minimum, which is a big theme of today. Socially, people are more connected. People are connected more reliably, between the south of Wales and the north. It is the only way to get to the north of England and Wales. And we want people to trust the railway. If it's closed all the time, who's going to travel on it? Who's going to have the confidence? We need to show people the train is the best way to travel. And so I think that is a really good social reason why this project's been great. Economically, I hope it doesn't flood every year, but the project will make its money back every flood that happens. You'll be able to see every time the floodwater washes away and the ballast stays in place and the trains are only closed down for a day instead of a week, it'll be very clear that the 4.5 million cost will make its money back in 4 or 5 years maximum. So economically, it's a sustainable solution as well. That's it on Vineyard Farm. Thank you very much for listening. I'll now pass over to Rupert to talk about a completely different climate-based problem.
Brilliant. Thank you, Rob. Oh, you can hear me. Brilliant. I don't even have to ask the question. Right, awesome. I'll get onto this climate change risk assessment tool. I hope that you're all relatively fresh after lunch. This is an 8-minute presentation, which typically takes about 45 minutes, and there will be a test at the end, so you need to pay attention. It's very important to me. Right, so we've got people up on the screen. Who are they? They helped me develop the tool. Alex, myself, James, and Kat. Unfortunately, they can't be here today, but I will be talking in their stead. So it's a tool to help asset managers manage climate change risks. How do you check for these risks? In a lot of our designs, our works, especially for bridges, 120-year life, our designers will be taking that into account. But are you taking climate change into account when you're doing a renewal, when you're planning that work? We need to assess the risks that climate change will have to the future of our railway. And it is actually a legislative requirement for us to assess risks in climate change. Let's have a little look, see what I actually developed. So with the team, we developed a 3-part tool. We had the Power BI tool, which is a fancy way of saying we took Excel data and made it look very nice and interactive. As I'm sure everyone in the room Excel it exists, but this is nicer and it looks prettier and it's got nice graphs and stuff. So we use that. We also got a lovely flow chart, 20 to 30 minutes, get your risk assessment done, and then you are covered, hopefully not covered in water. User guide as well. We've got some extra data to help asset managers answer the questions, answer the big questions. Is this going to survive the next flood? Is it going to be washed away? Is heat and cold a factor on your rail in the area? Let's have a little look-see. So, Power BI tool. This will hopefully give you extra information to inform a decision. It is based off of delay minutes, which I'm sure most of the people in this room love. But we're trying to use it in a positive way. So we're saying, okay, you've been delayed by a weather event, right? But in the future, with 2-degree and 4-degree increases in temperature, we talked earlier a little bit about 2-degree, 4-degree increases from climate change. If you have those, do you know how much more that's going to cost you? There's some high confidence predictions out there for heat, cold, wind, and flooding, coastal and inland, that give you those kinds of figures. How much worse is it going to get? Or better in some cases, depending, because you'll get less snow in the winter, or maybe more depending on where you are. So we factored those in, and we can give you information on how much worse it's going to be if we hit that 4-degree. And you have that data, so you know how much more it's going to cost you. If we keep delaying the railway, if the flooding keeps happening and it keeps getting worse, how much more is that going to cost the taxpayer? And how much money could you spend to renew that asset in a different way? Maybe put a bit more mitigation in place so that your structure survives the changes that climate change is going to bring to the UK. And it is limited to Wales and Western. There is no, there's so much data. There's so much data. So we're not expanding beyond Wales and Western for now. The data exists for the other routes, but man, it's so much data. So yeah, if the Scotland region or any of the other regions wants to take it up the mantle, they'd be more than happy to look at the thousands of lines of Excel data and make changes based on that. So yes, here is the Power BI tool. It'll look a lot bigger on your computer screens. I hope you can all read some of this stuff. I have taken out all of the money data because I'm not allowed to tell you how many millions of pounds we've spent on delay minutes according to flooding and stuff like that. But if you are a member of Network Rail and in Wales and Western and an asset manager, email me at rupert.toppin@Network Rail and I'll get you access to the tool. So yes, it's got all kinds of filters and information. You've got Cardiff, Central, East, Shrewsbury, West. You can filter it by financial year. You can see all these lovely colors over here. Heat, lightning as well. We don't factor lightning in for climate change, unfortunately. There isn't any high confidence predictions for that one. We've got heat, cold, wind. You can see all of your factors in there, and you can see where they've been affected. Big ones around Swindon, big ones around Reading and London. And like we were talking about with the washouts earlier, that will come onto here as well. So this can really help inform your decision. You can zoom right in, see where your site is and see, oh gosh, we've spent a lot of money on delay minutes at that site. And in the future, it's only going to get worse. Why don't we spend some money to save some money? And that's basically what this tool is. And like I said, there's the 2-degree and 4-degree stuff as well. move on. So the actual flowchart assessment, I've got a really simplified version, but essentially it's the main document, takes about 20 to 30 minutes to do, probably a bit less once you've done it a few times, and it's just one page. One page for your risk assessment. Admittedly, there are some background pages as well, but it's like one page for the most part. Here's your flowchart. So this is very high level. I'm going to run through it real quick. Do I have time? I do have time. Identify your asset. So what is your asset? You've got a bridge, you've got a culvert. What have you got? Some rail? You've got some ballast? Is it going to be in the rail for more than 10 years? Take this bottom path with me. You check the Power BI tool, you zoom into your location, you realize that we spent a god-awful amount of money on flooding in that area, and it's getting worse. So you start to bring together a remit. You're thinking, okay, this is going to cost me a lot more in the future. Can my asset withstand the climate risks faced? It's a good question, and it's got a lot of background information in there. Unfortunately, this relies it relies a lot on the information in the user guide. That's a 1.2 and 1.3 in the user guide. That's not a network rail. The 1.2 and 1.3, that's not network rail standard numbers. But we do have more information available to you all for that kind of stuff and relying on your own knowledge of the asset as well. Do you implement mitigation to fix your asset? Is it the case that it's costing so much every year with the flooding or the heat or the cold that you need to put that mitigation in, and now you have these extra numbers, extra financial data to back it up? And then you should review it as well, because at the end of the day, climate change is changing. And in the future, that was really bad. Climate change is changing, and the predictions will change as stuff becomes more high confidence. Maybe in the future, we'll have high confidence predictions for different types of weather events. I don't know. And that will be your climate change risk assessment complete. It's worth noting that if your stuff is only going to be in the railway for less than 10 years, don't worry about climate change. That's fine. You can just review it again later on. Right, and the user guide. So yes, extra information to help you make an informed decision as an asset manager. You've got your UK CP18, so UK climate change predictions. That is 2018 when it was made. So there will be a new one. I think they're every 5 years. So there will be a new one in the future as well. So keep your eyes peeled for that if you are a climate change enthusiast. Additional documents and network rail standards and documents that will help you make an informed decision about your asset. And that's pretty much it. It's a 20 to 30 minute risk assessment, uses real world data, and it uses real climate predictions, and it's handed over to the Western Wales Regional Sustainability Team. I am no longer maintaining it. That is their job. So I will hand over to Chris now. I don't actually have to hand over the mic, do I? No, you got one. Perfect. I hand over that. Okay.
Pointer. Thank you. Hi all, so I'm Chris. I'm here to talk about the 7 estuary earthworks that have recently been completed. Some of you might have passed on the way here if you came here from Cardiff. So it was a collaborative effort between mainly Network Rail and Tasika. It was a very collaborative effort between the whole Network Rail team internally as well. So it was a fast turnaround for the project due to the rail access that we got given. So therefore, the sponsors, delivery team and the design team had to work collaboratively from the get-go, and that enabled this project. And without that collaboration, we wouldn't have it. And then Tasika came in and worked collaboratively with us to complete the project. So, as a little bit of background, location-wise, it's on the 7 estuary near Newport, about 25 miles northeast of Newport, if anyone knows where Newport is. And then, so it's just along the 7 estuary, which has the highest tidal range of anywhere in the UK, in case anyone was interested. So, the importance of the project for the route. So, it's a major part of the Wales and Borders route. It's a key diversionary route for the Severn Tunnel. So, if there's any maintenance works in the Severn Tunnel, this route is utilised to deliver any freight or passenger between Wales and all of England. It has 43 freight trains a day. I know someone mentioned earlier that we didn't talk about freight enough, so just pointing that out. And it was also a 7-week blockade access with some freight train hand back in the evenings for the Severn Tunnel maintenance that was being completed as well. So it was unprecedented access that we normally wouldn't get given, and that's why it was such a fast turnaround. So, the importance of the works and the challenges faced. Some of the challenges faced is these earthworks are the largest and most complex in the Wales and Borders route. Some go up to 55 metres high, which is incredibly high. I've been up there. Wouldn't recommend it if you're scared of heights. So also you have, it was the highest risk of the whole Wales and Borders route, and that's why it was picked for the works that required. It had 5 major landslips between 2020 and 2022, which cost over 200,000 delay minutes. So anyone who knows how much delay minutes cost can rack up how much that cost and why the works were so important. But because of these delay minutes and because of the access that we got given, it had to be a fast turnaround. So all of this, from the conception to the tender to the delivery, was all completed within a year for the phase 1 section. So you know, as many of you know, railway projects don't normally have this fast turnaround. Normally it takes years rather than a year. 12 months is a very short turnaround. So as Rob mentioned, this project also is on the Wales and Border route, so it has limited access. Wales roads, as everyone knows, just there's no roads, minimal. No lorries, that's all I'm gonna have to say. So that's why I'll talk about in a sec that everything got delivered via train, just to minimize the impacts on the roads in the nearby. There was also a lot of ecological constraints. There's a triple SI site, the Severn Estuary, and there's a lot of dormouse and all other furry creatures that Jane mentioned earlier. So currently completed in 2022, it was between 129 miles and 130 miles and 880 yards on the South West Main Line 2. It was a slope regrade of discrete sections, so the most high-risk sections were picked, and then they were regraded mechanically. Following that, then that led to 17,000 tons of material being removed. This material was removed utilizing around 20 engineering trains, which were full and taken to a local waste management plant. Following that, we installed 27,000 meters squared of coir matting, as well as galvanized steel matting to create a passive mesh system for the areas that required it. To keep that mesh on, we used over 1,000 nails, soil nails, which were up to 10 meters in length. I don't know why they call it nails, it should be bolts. Humongous things when you see them. They say nails and you think like 2 centimeters, but no, 10 meters is ridiculous. And then we also installed 10 meters of legato blocks, which you can see here, in case anyone wasn't certain what legato blocks were. They're just a physical barrier, stopping if anything does fail. So for the video, will it work? No. Can I have the video, please, if that's okay? So here you can see some of the works here in one of the sections that was regraded. And here you can see the mesh and the coir matting already being installed and implemented here. Here you can see them loading the engineering trains using long excavators. And you can see how much soil was removed from these, and you can see how much of a high risk it was. Here you can see they began drilling, and you can see how dusty it was in the middle of summer. So it's scorching heat in a 37-degree heat, and you can see just how little water was actually on that slope. And here you can see the coir matting being unrolled down the slope in a controlled manner, and then being pinned using smaller nail pins. You can see some of the workers here, so it keeps in line and acts as a single unit. Here you can see some of the workers scaling the soil. Some of the rocks were quite small, and therefore a long-reach excavator couldn't reach them and wasn't applicable. So we used IRATA-trained operatives to then remove all that soil. And so the phase 2 works, that was phase 1 initially, that was completed in 2022. Phase 2 will be completed next year. It will include a lot of the same works, just higher mileage of the previous works, between 131 miles and 220 yards and 132 miles on the South West Main Line. It's currently, the tender's just about to begin in December, so we'll hopefully know the contractor by February, hopefully. It includes same works, so the passive mesh system, including additional drainage works, vegetation works, and also there will be some drainage installed. So for the outcome, the phase 1 works made a more reliable railway. It includes a lot more climate resilience. So with increasing climate change, there will hopefully no longer be any more landslides, and then obviously just a more reliable, if anything happens with the standard of the tunnel, this will be more reliable. So it increases the experience for the passengers and stakeholders, both for freight and passengers, and it also means a more manageable railway, so less maintenance required in these areas. So for sustainability aspect of it, this project was amazing. So when we used erosion control matting, we used QUA, which is biodegradable, lower impact, lower carbon footprint as well, rather than their geopolymer alternatives. We used the galvanized steel mesh, which increased the lifespan due to the estuary habitat rather than the stainless steel. Additionally, we reused legato blocks, so mentioning the circular economy, we utilized previous legato blocks which were still usable from a different work site to then implement rather than purchasing new ones, also reducing the carbon footprint of this project. And as I previously mentioned, we utilized only trains for the removal of the whole soil. As you can see, 17,000 tons of soil to be removed by lorry is a tremendous amount and possibly impossible based on the area. And now it will require minimal maintenance for the years to come. And that's it. Thank you very much.